Hey y'all, this is an intro lesson on confidence intervals. So this is just kind of a little preview lesson of what we will be getting into in the next couple videos I make about confidence intervals. So we are going to use something that we've already been talking about several times, and that is the empirical rule. So if you'll just take a second to remember that before we get into it, and we'll hop right in. So we are going to use the empirical rule, and we're using the empirical rule to form these confidence intervals in this section, in this video, so that we can estimate the population mean. So we already kind of talked about a little bit with the sampling distribution of the sample means. We took samples of different sizes, and we found the means of all the samples of all the sizes, and then we took the mean of all the samples, and that was our sampling distribution, and that helped us find the population mean. This is another way to help us kind of narrow down what that population mean might be. So one way to make inferences about a population mean, which we know the symbol for that is this weird little mu, without taking a census, is to estimate it using the sample mean. So think about a couple examples of populations that would be difficult to collect data on, collect a census on, because of how vast it is. We actually do a census, the government sends out a census, and everyone gets polled on this stuff, and you give them all your information, whatever. But if we were doing a study, a statistical study, what would be a population that would be really hard to gather data on as just one person? I would say, as a teacher, the one that pops into my mind that I use in a lot of my videos is maybe all of the students at a university. There might be thousands, tens of thousands of students at a university, and if I wanted to take a census, it would be kind of hard to get a hold. First of all, even if I could get a hold of everybody, and then if I could get a hold of everybody, gathering all that data just as one person would be really difficult. So all students at a university. You probably have a different example, and that's okay, as long as it's we use the word all. That means the population, and then maybe it would be a very large amount of subjects in the study. So the sample mean is what we use to help us estimate the population mean. We call this a point estimate of the population mean. And a point estimate applies the use of a statistic to estimate any parameter. And we know that a statistic is a value used to describe a sample. And a parameter is a value used to describe a population. So when we say statistic, it could be mean, median, mode, standard deviation. So that's just kind of all-encompassing, and same for parameter. The sample mean is usually not equal to the population mean. So we can expect some sampling error. And to indicate the accuracy of a point estimate, we calculate a confidence interval that includes the true value of the parameter within a certain level of confidence. So here's that empirical rule. In the empirical rule, how many standard deviations above or below the mean did 95% of the data represent? How many standard deviations was that? If you remember the empirical rule, another name for the empirical rule is the 68, 95, 99.7 rule, where 68 represents 1 standard deviation, 2 is 95, and 3 is 99.7. So how many standard deviations above or below the mean is 95% of the data? 2. And you can draw a little picture of that. We had a bell curve, and we had the mean. Whoops, it's a little off center. And then we had, one standard deviation above, one below, two above, two below, three above, three below. And we know that this represents 95% of the data. And what formula, this is kind of a recall, this is still part of the recall, what formula do we use to find the standard deviation of the sample mean? So not the standard deviation formula, I don't want that, not for this. It's a little complicated. The standard deviation of the sample mean. It involves a square root, which is pretty, normal for standard deviation, but it involves a square root. It also involves the standard deviation of the population. So if it's not coming to mind, standard deviation of the sample mean is the population standard deviation over square root n. My little square root n got kind of lost in the abyss. Let me try to fix that. There we go. Where n is the number of subjects in the sample. A margin of error comes from the distance between the point estimate and the upper or lower bound of the confidence interval. So this will all make sense in a second. It's not too hard. We have some information here. We have the sample mean is 20, the sample size is 36, and we have the population standard deviation of 3. Our goal is to find a 95% confidence interval for the population mean. So I haven't actually really given you a formula to find the confidence interval, but if we can think about what a confidence interval is, we can think about 95% of the data and tie all of that together, then hopefully we can kind of come up with what that looks like. So if we look at the picture here, we know that the sample mean is the center. It is a measure of center, so it's going to be the center. And then we also know that the upper bound of 95% is 2 standard deviations away from the mean. We also know that the lower bound of 95% is 2 standard deviations below the mean. So this is going to create a lower bound and an upper bound around the mean. So we can use those pieces to help us figure out what those bounds are. And we can use those pieces because we know certain pieces of information about the data. We know that for 95%, that represents 2 standard deviations. Whoops, yeah, that's right, standard deviations. We also know that the center of our upper and lower bound is going to be X bar, which in this case is 20. And we know that if we want to find the standard deviation of the sample mean, that we can use our little formula. So that's going to be 3 over square root 36, which is 0.5. Which means that if the standard deviation of the sample mean is 0.5, and we want to figure out the upper bound, let's look at our picture. We know the center. We know one of the standard deviations. We need to know 2 of them. Then we can say that the upper bound is found by X bar plus 2 standard deviations. And the lower bound will be X bar minus 2 standard deviations. And usually how you're going to see that is this plus or minus symbol. and that will give you your interval. So go ahead and try it and come back. If you calculated this, you should have gotten an interval from 19 to 21. And it says, identify and interpret the margin of error. So your margin of error is this wiggle room here, the plus or minus 1. And then to interpret it, we say that, running out of room here, we don't say that, but I am running out of room. We are 95% confident that the population mean is between 19 and 21 with a margin of error of 1. Oh, you can't see the bottom. There you go. So the margin of error is how much wiggle room there is. You probably wouldn't say wiggle room, but it's how much buffer there is for our estimate. And basically what we're finding is, I have to go to the next page. So I ran out of room on this page. I can show it up here. We have our point estimate, got the I, plus or minus our margin of error. And our margin of error comes from how many standard deviations above or below the mean is, which comes from our confidence level. So it all ties in together. This ME stands for margin of error. I didn't tell you that part. Hopefully you got that. Okay? And express the endpoints of the confidence interval in terms of the point estimate and the margin of error. I already kind of did that on the previous page, just because it was part of the calculation. This right here is what it's asking for. Express the confidence interval in terms of the point estimate and the margin of error. In this form, we can see the center and our margin of error. And so it's kind of nice because it breaks it up. Point estimate plus or minus margin of error. And then in the next step, that's where you actually add 1 and subtract 1, and that gives you your upper and lower bounds for your 95% confidence interval. That's so fun. Okay, I have an example here. These are US wedding costs. It's a sample of 20, and you are going to be working on finding a confidence interval for the population mean of US weddings. And so if you would pause it and work on these questions and then come back and check your work, that would be really good. See you in a minute. So hopefully you at least got the first two. If you tried C, you probably got stuck. So when it's asking for a point estimate, it wants the sample mean, which indicates that you need to add up all the costs and then divide by 20. So you should have gotten a sample mean of $26,326.90. And it asks if the point estimate is likely to equal the population mean. The answer is no, because it is only one sample, and it's also a small sample, so it's not likely to be equal. Now, if we took a whole bunch of samples of size 20 and then found the mean of those for a sampling distribution, then yeah, maybe, but not so much. And then in part C, it says determine a 95% confidence interval for the mean cost mu of all recent US weddings. Well, we need the standard deviation, the population standard deviation, in order to do that. And I did not write it on here that I can see, so you probably got stuck. The population standard deviation is $8,100. So now knowing that, you should be able to finish this problem. Sorry about that. What you should have found is that the standard deviation of the sample mean is $1,811.22. And remember, we're doing a 95% confidence interval, so that represents 2 standard deviations above or below the mean, which gives us this little formula. This is my mean, above or below, 2 standard deviations. And then if you type that in separately, there's not really a plus or minus key on most calculators. So you have to type in minus and then type in plus. You should get these values for your upper and lower bounds. And what that means is we can say we are 95% confident that the mean cost of all US weddings lies between those 2 values. Now remember, these 2 values represent the upper and lower bounds. So if you're just given these, we can find the sample mean by averaging them because we're looking for the center, the middle. And we can also find the margin of error by figuring out the middle and then figuring out the distance to whatever end. So let's say the question gives you this only, and it says, what's the sample mean? In that case, you would add these 2 values together and divide by 2 to find the center. Once you have the center, then you can do the margin of error. So remember that the interval comes from your point estimate, which in this case is sample mean, plus or minus your margin of error. And so in this case above, our point estimate is the mean, and then 2 times our standard deviation is our margin of error. So if we wanted to actually figure out what that is, that's 3,622.44. That's our margin of error. So we could write this as 26326.90 plus or minus. Our margin of error was 3622.44. And that is all for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I would be happy to help.